So now we can begin to set up our routes. And just so you know, we're setting up our Express routes before building out the client-side blog. So for all of these routes, we haven't yet set up the client-side version of these CRUD operations that we're going to see in a second. So yeah, just again, we're setting up the Express first, and then we'll set up the client-side blog. So let's first start by going in our routes file, routes.js file, and importing the pool object that we just initialized in the last section. So to import it, we just do var pool equals require./db. And then as a comment, we can write post route section. So this will let other engineers know that this section will hold the routes for the posts. So we can now begin setting up our routes. So our first one will be to get all the posts. So we start off with the router.get. And remember, get is an HTTP method that basically says we're getting some information from the server. So you would not use .get for any other routes besides getting data from the server. And we'll see like there's different words for whatever type of request you're making, like .put and .post, which is posting data to the server, and then .delete, which, you know, obviously is deleting data from the server. So there's each CRUD operation has its own word that you have to use when making a request. And then the actual route will be /API/get/all posts. And this naming scheme is important because /API tells us this is an API request. /get tells us this is a GET request, and /all posts is saying what we're getting from the server. So our first argument will be a string of the relative path, and our second argument is actually going to be an arrow function. So let's declare 3 arguments in the parentheses: rec, res, and next. And rec means the request, res is the response, and next is a middleware that will help us with error handling. So we'll now declare curly brackets for our arrow function, and we'll do pool.query. And remember, pool is the same pool that we set up in the db.js file, and .query is a given function that we can use to make SQL queries. So we'll need to make a SQL query to get all the posts from our database. So this is a very basic query, and it's going to be select star from post, order by date created. So select is the keyword that we use when we're trying to select certain rows from a column. Star means all. So select all from post. Post is a table, and then order them by date created, descending. Descending meaning the newest post first. So for the second argument of pool.query, we will need yet another arrow function, and this is going to be nested inside the first one. So this arrow function will take 2 parameters, QErr and QRes. QErr means query error, and QRes means query response. And inside the code block, we'll do res.json and then pass in QRes.rows. So res.json means the response will be turned into JSON format, and what will be turned into JSON format would be the query rows. So remember, when we make SQL queries, we get back rows from a column or a table, and in this case we're getting all of our posts from the post table. Next, we'll set up a post request to save a post to our database, and this will be /API/post/post2db, and in the same way it will require a arrow function as the second argument, and this will be set up the same way as we saw in our previous route. However, unlike our previous route, we actually need some data from our front end for this route. We're not just arbitrarily getting all the posts from the back end. We need to save some data from our front end client. So how we do this is we first create a const called values, and then we create an array, and then each data from our front end is contained in rec.body.title. So the entire rec object is pretty large if you console.log it. All we need is the data from our front end. So we do rec.body.title. So the body of the request contains the title we got from our front end. And we do this for body, the body of the post, the UID, which is the user ID of the user who submitted the post, and the username of the person who submitted the post as well. So we start off with pool.query again, and then the SQL query to submit a post to a database would be insert into post, in parentheses title, body, user ID, author, and date created. And then we do the values. Values would be $1, 2, 3, 4, and then the now function. The now function is a given psql function, and we can use it here like so. And $$1 means the first argument in the array. And same with 2, 3, and 4. It's saying the first, second, third, and fourth argument of the array. And notice it has to match up with the order that we declared it in post. So insert into post, and then title, body, user ID. The title is the first column of the value we're going to insert. So your first element in your array has to be the title, because the first argument in the post parentheses is title. So it has to match up and line up. So your values, every element in the values parentheses has to match up in the post parentheses. And also one thing to note, if you want to do multi-line SQL queries like so, I'm not using parentheses, I'm actually using backticks. So backticks are the symbol that's it should be the key under the escape key on your keyboard. So they're not parentheses. Notice they're backticks that I'm using to make this SQL query multi-line. And then next we pass in values. And again, this is the const values array we set up, and we pass it in here separated by a comma. And then we do the qarr and qres arrow function that we saw in the last SQL query we set up. And here I'll also show you how to use the next middleware. So we do if qarr return next qarr. And this is basically a better version of handling asynchronous errors. So if you have a synchronous error in Express, it can be handled easily. You just do throw new error and then pass in a string. But with next, it makes it easier to handle asynchronous errors. So next, basically, if you get an error, next basically passes on the error to the next handler that actually processes it. And this is what makes it have better asynchronous error handling. And then the next array, we can just do rest.json qrest.rows. But remember, this is a post request. We're just sending data to the database. So in our response, what we're going to get back is a status code from the server. And if everything is working, we should get back a status of 200, which means the server sent back a okay, everything's working code. So next we have a put request, and this is the update request in the CRUD operations. So CRUD is create, read, update, delete. And these are the four main basic operations that you see in web development. And put is the update of this CRUD operation. So we do router.put and then API/put/post. And then the same way we do rec, res, and next as in the arrow function. And then we also need values here as well, because we're going to be sending data to the database. And we do the same exact thing. We do title, body, user ID, and we also have a new one, PID, which is going to be the post ID. Because remember, we're making a put request, so we have to look up the post that we want to update, and we do this with the post ID, which is PID. And finally, we just have the username. So in the same way, we do pool.query, and then the put request in SQL is going to be update posts. So update the post table and set title equal to $1 and then the same body, user ID, author, and date created. And we don't use the PID here. We're not setting the PID because it doesn't change. And again, $1 just means the same thing it did in our post request. It is the first element in the array, but instead of having a separate values clause, we just set it here like so. Then we need our where clause, and this is the condition we're going to use to look up our post. So the where is just going to be where the PID is $4. So update the post, set the title to this, this, and this, where our PID, our post ID, is equal to the PID. And then we do comma values, and again, this is the same values. We set up the array of values, and then another comma, and then qarr and qres. And we'll just do rest.json qres.rows. Since again, we're sending data to the database, we're not expecting anything back. So what we will get back is the status code, and this will let us know if everything's working. And now we have our delete route, or I should say routes, because we will need two routes for handling delete operations. So the first one will be to actually delete the post comments, because we can't just directly delete the posts because certain posts will have comments associated with them. So if we delete the posts, then we'll just have a bunch of comments sitting in our database that are not attached to a post. And not only that, but we can't even do this in psql because of the foreign key constraint. And we'll discuss foreign key constraints in a later section, but we just have to know that we can't just directly delete posts because they might have comments with them. So let's first create a route for deleting the post comments before deleting the actual post. So we can do /API/delete and /post comments. And then the same exact way, we need an arrow function as a second argument. So how we will delete comments is by looking the comment up with its associated post ID. Remember, when we created the psql schema, we set up each comment to reference a post ID. And this post ID is exactly the same as the post ID that's in the post table. So because of that, we can just delete all the comments associated with the post by just using the post ID in the where clause as a condition. And this will easily just delete all the comments associated with a post. And of course, this post ID is going to be coming from our React front end. And we can just save it in a const called post ID, and it's going to be contained in rec.body.postid. So our SQL query can be very simple. It's just delete from comments where post ID equals $1. And remember, comments is a table that contains all the comments, and post ID is actually a column in each comment that is referencing the post ID, the PID in the post table. So the post ID is actually a column in the comments table that's just referencing post ID, the PID. And then after our SQL query, we do comma and then array post ID. So this is another way to pass in values. You, instead of wrapping rec.body.postid in an array, you can just wrap it in an array here. And then comma and then qr and qres as we've seen before. And in addition to receiving the server status code, we can also console.log qr. And now that we have the delete route for deleting the post comments, we can now delete the actual post. And we'll do this with the post ID as well. So we can save the post ID in a variable and then pool.query delete from post where post PID equals $1. And that's just the post ID. And on our React front end, we'll actually be calling these two functions sequentially. So we'll run the delete post comments first on our React front end, and then immediately call this one right after. And similar to the other functions, we can just do qerror and qres, and then console.log the error and get back the server status code. And this is it. This is the 4 main routes we'll need. These are all our CRUD operations. So these are the main routes we'll be using for our blog for making posts. And in the next section, we'll see similar CRUD operations for the comments.